Okay, so we're going to start our new unit, and the first thing we're going to do is look at index laws. Now, these have been covered since about grade 7 you start learning these, so some of them you'll remember, some of them you'll need a bit of a refresher, but we're going to do this before we go into exponential functions. Okay, so when we're looking at index laws, there's a couple of different names for them. So it's the little letter or number up the top of the number. It's sometimes called an indice, it's sometimes called a power, and it's sometimes called an exponent. This here is pulled straight off your formula sheet on the second page, so they call it index laws there, but when you see it a bit later on, they're going to be called exponents, as in exponential functions. Okay, so just keep in mind that those two things mean the same. So what we've got here, we've got a whole list of index laws, and we're going to go through them one by one, starting with multiplying, so starting right at the top. And you'll notice with these formulas that a few of them, you need the same base, so the same, I can't even say it, the same letter down the bottom here, or the same number down the bottom for the index law to work. So if you had x to the power of 2 times y to the power of 2, you cannot use these index laws. Okay, the bases need to be the same. Okay, so to start with our multiplying. So when we multiply two terms with the same base, has to be the same base, we add the exponents. Okay, so we've got our formula there at the start. So our bases are the same, they're both a, and our powers, our exponents, are added together. Okay, so I've got two examples here. The first one's quite easy, second one's a bit harder. These are both quite a bit easier than what you will see in a test, but we're going to learn them one by one and then bring them all together at the end. Okay, because your questions will normally take into account a lot of different index laws. So I'm going to start with this first one. The first thing I'm going to do is check that the bases are the same. 3 and 3, yes they are. Okay, so if my bases are the same, I'm going to add the powers. Okay, so this would be 3 to the power of 10. And that's it. Okay, the second one, it gets a little bit trickier because I've got numbers there that I could times, but they haven't got the same base. Okay, in fact, they haven't got powers at all. So 2 times 6, we're not using the index laws because the index laws won't work for them. So we're just going to go 2 times 6 as normal. Okay, my A's, they have the same base. Okay, and they're both to the power of 1. So because they've got the same base, 1 plus 1. Okay, same with the B's, they've got the same base. So it's B2 plus 10. Notice how I'm splitting up these terms. So I'm collecting all my numbers first, then I'm dealing with all my A's, then I'm dealing with all my B's. Okay, between these, there are little invisible multiplication signs. So it really can just be swapped around into any order that you like. Okay, and that's what this index law deals with when we're multiplying. So let's simplify that. 2 times 6 we know is 12. A to the power of 2, B to the power of 12. Okay, and that's it. We can't simplify any further because our bases are different. Okay, so that's the first index law, multiplying. So the second index law is when we divide. Okay, so you can see my formula here taken from the formula sheet. When the bases are the same, they're being divided, we subtract the powers. Okay, so I'm going to do that with my two examples here, remembering if you need more examples, there is the whole examples sheet and the examples video. Okay, so these ones are quite simple again, and they will get more complicated as we go along. So I'm going to start with my first one. Again, I'm going to check first of all that my bases are the same, which they are, they're both 3. And knowing that my bases are the same, I'm going to subtract my powers. So 10 take away 5. Okay, which gives me 3 to the power of 5. Okay, so fairly simple, and just keep in mind that that formula is there on your formula sheet for you to use. So you don't need to memorize them, you just need to know how they work. Okay, this second one I've put a mix of some bases with powers and some just normal numbers. Okay, so we're going to go through one by one. I'm going to start with my numbers. Okay, 10 and 5. So neither of them are in index form. So neither of them are a base to a power. So I'm just going to approach them as usual. 10 divided by 5 would give me 2. Okay. Secondly, I'm going to look at my A's. So I've got an A here and an A here. Bases are the same. So I'm going to collect them and I'm going to take away their powers. So A to the power of 5, take away 3. And I'm going to do the same thing with the B's. B to the power of 3, take 2. Now, if you have, say, a C here and nothing over here, you would just leave it as is, okay? Because it's not being divided by anything, it's just being divided by 1, so it stays the same. Okay, but those that are on both, we have to collect them and we have to deal with them. So A to the power of 5 take 3 would be A to the power of 2, and B to the power of 3 take 2 would be B to the power of 1, or just B. Okay, another way you might see them, I'll just draw one in the middle here, would be something like this. Okay, with that fraction bar, which means the same thing, we're still going to divide. So we divide numbers first. 20 divided by 10 would give us 2. X to the power of 5 take 2, which gives us 2 to the power, x to the power of 3, sorry. Okay, so whenever you see dividing, it might be an actual dividing sign, it might be a fraction bar. We're taking the powers as long as the base is the same. The third index law is raising a power to another power. Okay, again, this is taken off your formula sheet. So if a to the power of m is raised to the power of n, then we're going to times m and n. And I've got 3 different examples there to show you this one, just because it can vary quite a bit on the format. Okay, so it's the same index law. In the younger grades, we actually teach it as like 3 different index laws, just to show how it works. But for this course, it's all rolled into one. Okay, so the first one is quite simple because it looks exactly like the formula. Okay, so 2 to the power of 3 to the power of 5. We're going to go 2 to the power of 3 times 5. Okay, which is 2 to the power of 15. Okay, so a power to another power, we're multiplying. Okay, the second one here is very similar. Apart from in my brackets, I've got 4 different things that I actually have to multiply that 2 by. Okay, so it's going to go on to each and every number and letter in here. Okay, the trick with this one is the 3 here is by itself. If a number or letter is by itself, we just put a little imaginary 1. Okay, so 3 is the same as 3 to the power of 1. And that makes it a bit easier for us to decide what to do. So we go 2 times 1, so it'll be 3 to the power of 2 times 1. Okay, so it's not 3 times 2, it's 3 to the power of 2. Okay, so just remember that one. Our A's are going to be to the power of 4 times 2. B is going to be to the power of 2 times 2. And C is going to be to the power of 3 times 2. Okay, so this line of working here, you do not need to do it. I'm just showing you what my thinking process is as I go. Okay, so 3 would become 3 to the power of 2, A to the power of 8, B to the power of 4, C to the power of 6. Okay, so raising a power to another power, we're multiplying the powers. Okay, and if there's no power on one of these numbers or letters, you just pop the power on the outside of the bracket onto it. Okay, this third example looks a bit different just because it has a fraction bar in it. That whole thing is meant to be raised to the power of 3, but my equation editor is not complying. So we're going to try this. It's the same as the second example. You just need to apply the 3 to the top and then to the bottom. Okay, so it would look like 2 to the power of 3, a to the power of 4 times 3 is 12. Okay, over 3 to the power of 3, x to the power of 9. Okay, so it goes on each and every number and letter in the bracket. Okay, so that's all you need to remember. Whatever's in the bracket, if it's to a power, the power gets times by the other power. If it's not to a power, like these numbers, it just gets the power put on the top there. Okay, and that's the third index law, raising a power to another power. Okay, so this is the fourth index law, the power of 0. So any number or letter that is raised to the power of 0 is just 1. Okay. This one, and the one you've got to be careful of, is that the 0 only applies to the letter or the number that it is attached to. Okay, so in this first case, it applies to the entire bracket. In this second case, it only applies to the A. It doesn't apply to the 3. Okay, and it only applies to the X. It doesn't apply to the 2. So you just need to be careful that when you see something raised to the 0, you just don't wipe everything out and say, oh, it's 1. Okay, so let's go through the first example. I'm going to do it the long way. If I was in a test or an assignment, I would look at that and I would say, well, it's raised to the power of 0. It is 1. Okay, but I'm going to show you the kind of proof for it. So remember before, when we have a power to another power, we multiply. So I'm going to pretend that my little 1 is there. It is there, it's just invisible. And I'm going to raise powers to another power. So 2 to the power of 1 times 0, a to the power of 4 times 0. Okay, 1 times 0 is 0, so it's 2 to the power of 0, 4 times 0 is 0, a to the power of 0. Now, anything to the power of 0 is 1 according to our formula sheet. So 2 to the power of 0 is 1 times a to the power of 0, which is 1, which gives it all 1. Okay, so you could have brackets with 40,000 different terms. If it's raised to the power of 0, it's going to be 1. Okay, that 0 applies to everything in the bracket. This second example here is a bit different. There's no brackets around it, so the 0 only applies to the number or letter that it's on. So our 3 stays the same, but our a to the power of 0 becomes 1. Okay, plus 2 stays the same, x to the power of 0 becomes 1. So it's 3 plus 2, which is 5. Okay, again, these are simpler than what you will see on an assessment piece. You will be given a problem that normally includes all or most of these index laws in the same problem. Okay, so there'll be zeros in there, and you've just got to remember that that makes that letter or number into a 1. Okay, and that's all it does. So that is our fourth index law. So our fifth and our sixth index law is where it starts getting a little bit tricky, and this is normally where the mistakes start getting made. So the fifth index law is negative powers. Okay, and a negative power is the same as writing the inverse of that. So it's the same as writing 1 over the same base to the positive power. Okay, like the zero index law, this only applies to the number or the letter that it's attached to. Okay, so example 1 down here, that negative 4 only applies to the a, it has nothing to do with the 2. Okay, so when we use this negative index law, we're not going to touch that 2, that's going to be left alone. We're only going to muck around with the a. Okay, so most answers, when they ask you to simplify, will specify that you need to write your answers with positive index laws. Okay, so if you've got any negative ones, you need to do a little bit of a switcheroo. So how I teach this to my younger grades is if it crosses a line, it changes the sign. Okay, so we're going to do the first one. Let's find a pen. So this negative 4 only applies to the a. Okay, right now this is like a fraction over 1. Okay, any number is a fraction over 1. So if we want to change this to a positive number, we're going to bring it from the top of the fraction down to the bottom of the fraction. Okay, and once it crosses that line, it's going to change the sign of the power. So the 2, we're leaving it alone, stays up the top by itself, and it becomes a to the power of positive 4. Okay, so only that letter or number that's to the negative and you want to change crosses the line. Okay, this second one is a little bit more complicated. So I've got the top of my fraction, my numerator, has one positive and one negative exponent, and the same with my denominator. So the ones that are positive we're going to leave alone, and the ones that are negative need to cross the line. So that will look like this. So a to the power of 2, that is fine where it is. B to the power of negative 3 needs to cross the line, so that's going to come down here. And as soon as it crosses that line, the power changes its sign. Okay, down the bottom, x to the power of 3, that's a positive, so it's going to stay where it is, we're not going to touch it. And y to the power of negative 2 needs to cross the line and come up. Okay, so it's only the letter or the number that the negative is attached to, and most questions will require you to write your answer with positive indices. And if they don't specify, just to be really, really safe, sometimes it's better to write it in both. So your answer and then with positive indices. Because once you get the hang of it, it doesn't take long to do. So that is our fifth index law, the negative ones. Our sixth index law is the very last one we have to do, which is the roots index law. Okay, and our final index law, here we go, is our root law. So you can see the formula there from the formula sheet has two different notations, but they are pretty much the same thing. I prefer this second one here, just because they normally put an m inside the root, so it's a bit handier, but you can use either. It doesn't really matter and doesn't make a difference. So my first one is going to be in root form. I'm going to change it into index form to solve it. And my second one, I'm going to use a combination of finding the square root and index form. Okay, so my formula here, okay, my base, which is a, in this first example is x. My power, which is m, is 4. And the power of the root is n, which is 2. So I can rewrite this as x to the power of 4 over 2, 4 divided by 2, x to the power of 2. Okay, that's it. So by changing it from the root form into index form, it actually makes it quite easy for me to solve. Okay, so I'm going to try the second one. And the problem I've got here is I've got a combination of bases to powers, and I've also got some just numbers. Okay, so 16 to the power of a half does not make much sense to many people. Okay, but what we can do, we know that a half, we can rewrite it like this. So we can actually write square root of 16. Okay, so the square root of 16 is 4. So in that case, transferring it from a index format to a square root format helps us a lot. Okay, same with the cube root. If it's just numbers, sometimes that helps clear it up. Okay, the numbers here, we could go the square root of a to the power of 6 and the square root of b to the power of 8. Okay, if that's how you want to do it, or you can leave it as, well, a half times 6 is 3. So a to the power of 3, and a half times 8 is 4. Okay, so that one takes a little bit of getting used to. You might want to have a look at some more examples for that one, as it is it's not kind of taught in the younger grade, so it might be the first time you're seeing it, or you might just have not seen it for a while. Okay, but we can change it from index laws to roots and back again, depending on what suits us. And if you're not sure, change it, see if it helps. If it doesn't, change it back. Okay, so that one can be quite useful, especially for whole numbers and perfect square numbers. Okay, so we have finished all 6 of the index laws. I will leave those bigger examples for the example sheet. Okay, so if you want to have a look at the kinds of questions you will be asked in a test, in an assignment in this course, that's what they'll be like. Okay, so they kind of take all of these into account and have a look at all of them. Okay, so that's the end of this video.